Hello students, welcome back to the 8th video of this playlist. In this video, we will be solving question number 17 from the most recent past paper of Physics Unit 4, that is the October 2024 Unit 4 paper. So let's get started with question number 17. The photograph shows a toy aeroplane suspended from a fixed point by a thread. We can see on the figure. So part A here, it is saying the toy airplane has a motor that turns a propeller. It turns a propeller. As the propeller rotates, it sweeps out a circle of radius 4.1 centimeter. So the length of each of the wing of the propeller, it is 4.1 centimeter. So as it rotates, it is sweeping out 4.1 centimeter of circular radius. The propeller pushes air backwards at a speed of 2.4 meter per second. So it is pushing air backwards at a speed of 2.4 meter per second. Part 1, it is asking to show that the propeller pushes a mass of air of about 3 times 10 inverse 3 kg backwards in a time of 0.20 second. So density of air is given as 1.3 kg per meter cube. Since they have given the density, so we can relate the density with the mass using this equation, rho equals to m/v. So density is known, we need to figure out the volume to get the mass, right? So to get the volume, consider what we know here. Volume is area of cross section times height, right? So the amount of air that it is sweeping out, it has a circular radius of 4.1 centimeter. So we can find out the area of cross section using this radius. And the height, we don't know the height. So to figure out the height, we can do one thing. Look, the amount of air that the airplane it is pushing off in the backward direction, it can be compared with a cylinder. It can be compared with a cylinder like this. It can be compared with a cylinder like this. So now we will just find out the volume of this cylindrical region. So they are asking in a time of 0.20 second. So let's consider the area of cross section. We know this is pi r squared. We can get the area of cross section using pi r squared, and this length would be the distance covered by the air particles in 2.4 seconds. This is what? Vt. 2.4 times time is given as 0.2 seconds. 0.2. So we can figure out the volume here. So volume of air, V equals to the radius. The radius is how much? 4.1 centimeter. So pi times radius is 4.1 over 100 whole squared. Pi r squared times, this is the area of cross section A. The length is 0.2 times 2.4, that much meter cube. So let's figure out the volume using calculator. 4.1 over 100 whole squared times 0.2 times 2.4. So 0.2 times 2.4. I forgot to multiply by pi, so 3.1416 multiplied. So you will get the volume of air, it is 2.534894 times 10 inverse 3 meter cube. So we got the volume. So mass would be how much? Mass equals to density times the volume. Density is 1.3. So 1.3 times 2.534 dot 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 times 10 inverse 3, that much kg. So let's find out the value. So 2.53 something. The answer that was saved as volume times 1.3. So that would give you 3.29536.247 times 10 inverse 3 kg. So this can be written as 3 into 10 inverse 3 kg. That's it. That's what the question in part 1a has asked to show. Fine. Okay, next is part 2 of A. In part 2, the question says to determine the momentum of the air pushed backwards by the propeller in a time of 0.20 second. So momentum P equals to what? mv. So the mass of air that has been pushed backward, it is 3.29 dot 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 times 10 inverse 3 times their speed was 2.4 meter per second, if I'm not wrong. Yes, 2.4 meter per second. So 2.4, that much kg meter per second, or Newton second you can say. So what you will get the value? 2.4. So that would give you 7.90886929 times 10 inverse 3 kg meter per second. So we can write it to three significant figures, that is 7.91 times 10 inverse 3 Newton second. That's it. That's the answer for part 2 of A. Fine. Okay, next is part 3 of A. Determine the forward force exerted on the aeroplane by the action of the propeller. Forward force. Okay, force is basically what? The rate of change of momentum. So force is equals to change in momentum. So change in momentum, this is 7.90 something times 10 inverse 3. This is the change in momentum over the time. How long the force has been act, how long it took for the change in momentum, 0.2 second. Okay, so change in momentum over the time, 0.2. So the value you will get here 0.2. Okay, this will give you 0.03954434964 that much Newton. So we can write it to three significant figures as 0.0395 Newton. That's it. That's the answer for part 3 of A. Fine. Okay, next is part B1. Okay, part B at first. The question says the toy aeroplane moves in a horizontal circular path of radius r at constant speed v. The thread is at an angle theta to the vertical as shown. Okay, we can see in the figure. So part 1 of B, it says the forwards and backwards forces on the toy aeroplane are equal in magnitude. Okay, so that means horizontally it is not horizontally, the forwards and backward forces on the toy aeroplane, it is equal in magnitude. So that's why it is moving with constant speed. So the question is asking to add to the diagram to show the other forces acting on the toy aeroplane. What are the other forces acting on the aeroplane? So definitely, since it is threaded at a point, okay, so along the thread there will be tension force acting on the aeroplane, which is the tension force. So this is the tension, and the toy aeroplane has its own weight. So weight will be acting downward. So this will be the direction for weight. These are the forces acting on the toy aeroplane. Fine. Okay, next is part B 2. Okay, in part B2, the question is asking to show that the angle theta of the thread to the vertical is given by tan theta equals to v squared over rg. Okay, so how can we show that? At first, consider the question says the aeroplane, it is vertically in equilibrium, right? It is moving with it is moving horizontally. Since it is moving horizontally on a horizontal circle, that means in the vertical dimension it is in equilibrium. So let's consider what are the forces acting vertically on the aeroplane. So the forces acting on the aeroplane vertically, this is the vertical component of the tension. Okay, this is T vertical, and in the downward direction the weight of the aeroplane, it is acting downward. Okay, so now consider the vertical component of tension. So vertical component of tension, we can consider it. Okay, this is the vertical component, this is the horizontal, and this is the resultant. So this is the theta, right? So this is T vertical, this is T horizontal, and this is T. So we need the vertical component. So let's consider cos theta. Cos theta equals to TV, the vertical component of tension. Cos theta equals to the vertical component of tension over the hypotenuse, which is T. So the vertical component of tension, it is T cos theta. So if you consider the forces vertically, the vertical component of tension, this is T cos theta equals to the weight mg, if you consider the forces vertically. Okay, so from there we can make T the subject, so you will have mg over cos theta. Okay, done. We have considered the forces vertically. Now consider the forces horizontally. If you consider the forces horizontally, the only force acting on the aeroplane, this is the horizontal component of tension, and this is the only force which is providing the centripetal force. So we can write horizontally the horizontal component of tension, this is it will be, it can be related by sin theta. Okay, so let's find out the horizontal component at first. So sin theta equals to T horizontal over T. So the horizontal component of tension, it is T sin theta. So horizontally T sin theta equals to the centripetal force mv squared over r. Okay, so we know that T equals to mg over cos theta, so let's put it here. So mg over cos theta times sin theta. Okay, I have to erase it. Okay, sin theta equals to mv squared over r. So m cancels out from both sides, and sin theta over cos theta is tan theta. So tan theta equals m cancels out, so you will get v squared over r times g. That's what part 2 of question B has asked for. Fine. Okay, next is part 3 of B. Okay, here the question is asking to calculate the time taken for the toy airplane to complete one revolution. Theta is given as 22 degree and r is given as 21 centimeter. So in part 2 we have showed that tan theta is equals to v square over rg. Okay, so from there let's find out the orbital speed, because we need the revolution time for one complete revolution. So v would be square root of radius is 0.21 meter times g times tan 22 degree. Okay, so let's find out the speed. 1022 degree times 9.81 times 0.21, then square root of answer, that would give you 0.912323642 meter per second. Okay, so this is the orbital speed. So orbital speed, it is equals to 2 pi r over capital T, right? So from there, let's make t the subject. We need that time period. So 2 pi times r, radius is 0.21 over the speed, orbital speed, this is 0.912 dot dot. So let's find out. So 2 times 3.1416 times 0.21 over the answer. So you will get 1.446276 seconds. Okay, so up to 3 significant figures we can write 1.45 seconds. So the time period is 1.45 seconds. And that's the end of question number 17. Fine.